We rounded up last week by stating the differences between quality assurance and quality control. Okay, this week we're going to start by discussing good manufacturing practices. Good manufacturing practices, GMP as it's often called. Now, the basic rules in any good manufacturing practice postulate that the manufacturer should maintain appropriate documentation and records. That is, the importance of documentation and records cannot be overemphasized in a typical manufacturing setup. Okay? Now, documentation in this case gives a detailed interpretation of what a manufacturing function has done in the past and what it's doing now. What are we saying here? That is, keeping a record in a typical manufacturing setup, that record will show what you have done in the past and what you are doing presently. Okay? Also, this documentation provides a base for planning what will be done in the future. So that is, if you have a record, if you have a document of what you have done in the past and what you are doing now, that record will help you to plan for what you're going to do in the future. Now, it is important to point out at this point that when government regulatory agencies, when they visit a manufacturing site, what are they looking for? They want to go through your documents and records. Okay, so proper documentation, it also helps the visibility of what? Quality assurance system. So if you keep proper record and documentation, it's going to help your quality assurance system. So having said all that, so what is good manufacturing practices? What is good manufacturing practices? Okay, good manufacturing practices is that part of quality assurance which guarantees that products are regularly produced in conformity with the set of standards. I take that again. Good manufacturing practices is that part of quality assurance which guarantees that products are regularly produced in conformity with the set of standards. Okay, don't forget I said good manufacturing practices often referred to as GMP. So if I say GMP, you know what I'm talking about is good manufacturing practices. Okay, now GMP is intended to mitigate the risks that are associated with what? Production. That is, good manufacturing practices is intended to mitigate the risks that are associated with production. And now I've identified two risks for the purpose of this course. Two risks that are associated with what? With production. One, this risk is called cross-contamination. Cross-contamination. Okay. Now, cross-contamination occurs when a starting material, intermediate product, or finished product is polluted by another starting material, intermediate product, or finished product. What are we talking about here? Assuming you have more than one product in your production line. Okay. Okay, good. Let's a typical example now. Let's say you have a plant. On one side of your building, you have you have a water plant. On the other side, you have let's say a plastic plant, for instance. Good, plastic plant. Now, don't forget, in a plastic plant, you may need to kind of grind some of your materials. If some of those materials you are grinding happen to come in contact with water, which you're trying to bottle on the other side of your factory, that's contamination right there. You're going to have particles of that plastic in your water. That's not a good quality. That's not a good product anymore. Okay, so that kind of risk is called cross-contamination risk. Okay, now the main sources of cross-contamination risk are human being. That is, even okay, good. If you work in that kind of environment, the one I just described now, if you touch any of those materials where you have plastic being manufactured, and without washing your hands, you now go to the other end where water is being produced. You'll be the carrier, or you'll be the carrier of particles now from the plastic plant to the water plant. So that was why I said the main sources of cross contaminations are human being, equipment, air, raw materials, and water. In fact, another good example is this: assuming we're not even talking of having more than one product in a single production line. Assuming you have let's just use a water plant here, and not too far from that water plant, you have like a milling plant, not too far from it. A milling plant, let's say solid mineral, for instance, and they mill something like maybe white Vespa. Now, if you pour white Vespa onto a milling machine, the moment you do that, what do you see? You're going to see particles coming off from the machine. And if that machine is left on for 8 hours, I tell you, you're going to have particles all around that place, flying around. And you have air is going to be carrying all those particles all over the place. So if your water factory is not far from there, even though you have only one product on your production line, particles of milled white Vespa can fly from your nearby factory to your own factory. And thereby, what do you have? You have a cross-contamination. Your product becomes what? Contaminated. Okay? Now, cross-contamination occurs mostly when there are more than one product in the production line. I think we've explained that. And I also said that it's possible, even if you have just one product in your product line, and there's a company that is a manufacturing company that's not far from you, your product can also get contaminated if it's not well protected. Okay. Another kind of risk that is associated with production is called mix-up. Mix-up. Okay. Now, mix-up occurs when one product is polluted by another product as a result of what? Human error, inadequate process, or plant design. Let me take that again. Okay. Mix-up occurs when one product is polluted by another product as a result of human error, inadequate process, or plant design. Okay. Now, mix-up may occur during labeling, okay, packing, or issuance of receipt. What am I saying? Now, assuming you have a product, you have that product in, let's say, in 1 liter, and you have another, in, let's say, 50 liters, and you have another one in 100 liters. But that's like way too big. Let's say you have it in 1 liter and 2 liters. Then you have, as a staff now, you have a label of 1 liter, and you now make a mistake of putting that 1 liter label on a 2 liter product. That's a mix-up right there. Putting the wrong label on a product. It can also be the other way around. When you take a 2 liter label and you make a mistake of putting it on a 1 liter label, that is what? That's a mix-up right there. Also, talking of packing, let's use the same scenario. Assuming you have the same product, but you have some of them in 1 liter, you have some in 2 liters. So if as a staff, you make a mistake of putting a 2 liter product in between a 1 liter product, then what happens? That's a mix-up. Okay, and it can also be the other way around when you put a 1 liter in between 2 liter product. How about issuance of receipt? Assuming you have let's say you buy 10 packs, I'll call it 10 cases. Let's say you buy 10 cases of product A, and you buy 5 cases of product B, and you already pay, you make your payment. Then you need your receipt in order to collect your goods from the warehouse. Let's see what happens. The guy who's writing the receipt, he can make a mistake by writing, you ordered for 10 cases of product A and 5 cases of product B. He might make a mistake of writing 5 cases of product A for you on your receipt, and then 10 cases of product B. And then when you take that to the warehouse, you discover if you are not the type that want to double check and cross check before you leave the warehouse, you're going to leave with wrong products. Because you'll be thinking, I paid for 10 products of product A, and then 10 cases of A and 10 cases of B. Now why am I getting 5 cases of A and 10 cases of B? What is happening in that situation is called what? A mix-up. Whoever wrote the receipt must have made a mistake of writing the wrong product for you. Okay. Now, so that's why I said mix-up may occur during labeling, packing, or issuance of receipt. Okay. Now, let's note this. Mix-up may be prevented by physical segregation of products with proper labeling and identification details. What are we saying here? Assuming you have similar products now, okay? Let's say you have one, like the one I said, you have one like that. One is 1 liter, the other one is 2 liters, but they are similar products, okay? Let's say they are like something like orange drink. What you want to do is you want to separate them. Put the ones that are 1 liter on one side with their labels. Put the ones that are like 2 liters on the other side with their labels to avoid what? Mix up. So physical segregation of products with proper labeling and identification details is going to save you from that headache. Also, proper design is essential for easy flow of materials. We're talking about design and the layout here of facilities here. If that is done, okay, right, it will also help to eliminate the problem of what? Mix up. Now, furthermore, packing should be done in compliance with the written procedures. Packing should be done in compliance with what? The written procedures. In all, to avoid contamination and mix-up, okay? To avoid contamination and mix-up, written procedure should be clear and precise. What are we saying here? You have laid down procedure that you are following in your manufacturing company. You do not need anybody to interpret the procedure to you. Once you are trained on that job, okay, you want to carry out an activity. Once you get there, you take the paper. Once you read it, you should be able to understand what the paper is telling you. It should be written in clear language, and it should be what? Precise. Tell you what to do and when to do it. So that's what I mean by clear and precise. Also, the written procedures should be followed in all tasks and activities to achieve the quality objective of the product. What are we saying here? Okay, you've been working in the company for so long. You're not going to depend on your memory. Oh, I've been doing this thing for ages. No, there are laid down procedures which you have to follow, and you have to follow that all the time. Not that, oh, when I worked yesterday, I followed the procedure. Today I shouldn't. No, you follow the procedure every day, all the time. Even if you have you have a day shift in the manufacturing company, you have night shift. When they come in, they follow the procedure. When day shift, when they come in too, they have to follow the same procedure all the time. Okay. Now, having said all this, we want to look at some rules guiding manufacturing. So some rules guiding good manufacturing practice. Okay. So these are called rules of what? Rules of good manufacturing practice. Okay. Now, the first one I want to talk about is what? Design layout right from the start. That's the first rule. Design layout right from the start. What are we saying here? Now, it is the responsibility of a manufacturer to design the layout for facilities and equipment right from the start. Okay. For example, production area should be laid out according to the sequence of operations. Production area should be laid out according to the sequence of operations. Now, let's say you have operations, you have say A, B, C, D, E. You're not going to have A, right, followed by C, and B is located at the end. No. If A is the first that is coming up, and after A, then B, let them follow that sequence. So that you'll be jumping around looking for the next thing to do or the next machine to use. Okay, that's why I said production area should be laid out according to the sequence of what? Operations. Right? Now, a well-organized layout will eliminate unnecessary movement in the production area. and also improve output. If your production area is laid out according to the sequence of operations, you won't have to be jumping around looking for what is not lost. When you are done on the machine, the next machine is so close to you. Okay? Or when you are done with like a semi-product, or from your own station, the next person is so close to you. You don't have to run up to a mile before you get to the next person that will take over the job from you. No. So your production area should be laid out in such a way that sequence of operation is taken into consideration. Okay. Now, in order to eliminate the effect of environment, okay, on the quality of your product, things like ventilation, lighting, air, water, temperature, and humidity should be controlled. Okay, we're talking about what are we talking about in this case? Now we're talking about getting the design right from the scratch. That if you design your facility right from scratch, you will even need to consider the effect of the environment. You're not going to neglect the environment because you cannot even exist without the environment. So you're going to consider the air that will be within your facility, the temperature that will be there, the lighting that will be there, water. All these things are things you need to consider when you are trying to design your facility. So if all these things are considered, what you're trying to do in that case, you're doing what? You're trying to practice good. You're trying to go in the direction of good manufacturing practice. Okay, and as a manufacturer, you want to do just that. If you do that, it's going to help you to do what? To get a good quality product. If you follow all those laid down procedures, the end result is that you're going to get a good product. You won't have to go back and say, okay, there's a defect here. The essence of all this is to have a defect-free product. That's the essence of having good manufacturing procedure in place. Because good manufacturing practice in place. You want to have a defect-free product at the end of the day. Okay, so we're saying that in order to eliminate the effect of environment on the product of a quality, you want to eliminate the effect of environment on the quality of a product. So things like ventilation, lighting, air, water, temperature, and humidity, they should be controlled. Okay. Now, furthermore, equipment should be designed and installed in areas where they can be easily cleaned and also suitable for their intended use. What are we saying here? Now, if you have your equipment now installed too close to the wall, one, if you want to work on that equipment, you need that equipment to perform an operation, to carry out some activities. If it's too close to the wall, you won't even have a place to put your chair if you need one. In fact, if you don't need a chair, you need to stand close to the machine, you don't even have a place to stand. So the equipment should be well installed in such a way that if you have to work with the equipment, you have enough room to move around the equipment to do what you need to do. Okay. Now, if you need to clean the equipment, it should be well installed in such a way that you have enough room to move around the equipment and do the necessary what? Cleaning. Because you cannot be using an equipment without cleaning it. Okay. So your equipment should be what? Well designed. Should be designed and installed in areas where they can be easily cleaned and also suitable for their intended use. Okay. Then equipment should be clearly labeled and calibration done at defined intervals. What are we saying here? Now, any equipment you have in a manufacturing environment, there should be a label on it. That label should be clear enough. It should be written in clear language. Even if you use glasses, you should be able to read it. We're not talking about the size of the letters here, but it should be written in clear language. Okay. If we live in Nigeria now, and the language we use in manufacturing setup is English language, then if you want to label any of your equipment, it should be labeled in English language, not in Chinese language. If you do that in Nigeria, a lot of people will not understand what is written on the machine, and that's going to be a problem right there. So you want to label your machine in a clear language. Okay. Now, calibration of an equipment should be done at defined intervals. This is very essential. For instance, now let's take this simple illustration in home now. Let's say, okay, like you have a thermometer. Now, if the thermometer is not well calibrated and it's showing 37 or showing 40, when it's showing 37, probably what it's actually showing you is -10 of what you're saying because it's not well calibrated. Or when it's showing 27, it's probably showing you +10 of what you're saying. So because of that, calibration of equipment should be done at defined intervals. In fact, you cannot negotiate that in a typical manufacturing setup. Okay, so your equipment should be clearly labeled and they should be they should be calibrated at regular intervals. Okay, now also we've talked about design layout, getting it right from the start. We also want to talk about validate process. Validate process. That is, if you want to maintain good manufacturing practice, one of the rules is that you want to validate what? Your process. Anytime there's a change in manufacturing process, okay, it is the responsibility of a manufacturer to validate its process. Changes do occur all the time. Okay, anytime that you notice a change, you need to do what? You validate your process. All validation activities should be well planned and clearly defined. Okay, and then if you validate anything, that means there's a change in the process. Your staff, they need to know. You need to let them know, okay, ahead of time. Let's say you receive a notice of change today. Now, today is a Saturday. I want to effect that on Monday. Okay, when they come in on Monday, the first thing you want to tell them, look, there's a meeting. We need to have a meeting. No matter that's a crucial meeting. There's a change in a particular process. This is how what we've been doing before, but this is what we want to start to do now. Okay, your staff, they need to know. Okay, and that's why we said all validation activities should be well planned and clearly defined. If it doesn't affect all the departments, you let them know. If there are ABCD departments in your manufacturing company and the change we are talking about in this case only affects department A, okay, other departments can go ahead and do what they've been doing before, but department A, they need to stay behind so they can receive a little training on what they need to do henceforth. So it's very, very important. A department that does not need to effect any change, they don't need to be told about a new change because it doesn't affect them. Okay. Now, another thing again, we're talking about the rules of good manufacturing practice. Another thing we need to know is write and follow good procedure. Write and do what? Write and follow good procedure. We're talking about two things here. Writing good procedure is one. Following good procedure is another one. It's another thing. Okay. So if you want to one of the rules you need to follow, okay, in order to be in conformity with good manufacturing practice is you want to write good procedure, and at the same time you want to follow the good procedure. Okay. So it is the responsibility of a manufacturer to have a good manufacturing written. Sorry, to have a good manufacturing process or procedure written down, and also to follow same. You don't just write it down without following it. You write it down and then you follow it on every activity that you perform. No activity is too small, okay, and no one is too big. Or everything you do is written in that document, and you have to follow that to the letter. Okay. Now, a manufacturing company may even hire a consultant to write the manufacturing procedure. What are we saying in this case? Some people are specialized in that. They understand all the languages, and they will be able to write the kind of procedure, the kind of manufacturing procedure you need in your company. They get paid for it. That's their own job. In fact, if you allow an outsider to do it for you, it's even better for you. But they will be like somebody that will assess whatever is happening in your company. They will look at what you have done in the past versus what you are doing right now. Okay. So we're saying that a manufacturing company may even hire a consultant to write the manufacturing procedure. In all, clarity and precision are key to understanding a manufacturing procedure. What are we saying here? Like I think I said that before, a manufacturing procedure should be written in clear language, in clear terms. You shouldn't be racking your brain before you understand the language, okay? And it should be precise. That's if you're talking about Department A, the things should say, oh, we're talking about Department A. If you're talking about Department B, you should be able to tell that, okay, they're talking about B in this case. They can't be talking about A and you'll be thinking about B, because what you see is what you get. Let's put it that way. Talking about manufacturing procedure, what you see is what you get. Whatever you see written down in a paper, that's what you're going to do. Is that okay? Now, rule number 4, identify who does what. Identify who does what. Okay? Now, a manufacturer should create what we call an organizational chart. Create an organizational chart. Now, what does that tell you? An organizational chart will tell you, okay, this is the MD here, this is the deputy MD, this is the general manager, this is the manager this, manager that. It tells you who does what. So there won't be conflict of responsibility. So a manufacturer should create an organizational chart and display it on the intranet or on a local notice board. Okay? If it's displayed on the internet or on a local notice board, any employee can go there and look at it. Okay, this is the position of this person, this is what he does. As such, everyone in the organization can see who does what. That's the essence of identifying who does what. You cannot hide it. Let them know that this is the GM. Under the GM, you have a manager finance, a manager production, manager marketing, and all that. So everybody will know all these managers that we have, they are all reporting to what? To general manager. So you should be able to identify who does what in a typical manufacturing setup. And it's one of the rules you want to follow, you want to obey, if you want to practice good manufacturing practice. Okay? Rule number 5, keep good records. Keep good records. What are we talking about here? Now, when you get to your workstation in the typical manufacturing setup, even though you have a procedure you have to follow, whatever you do in a day, you need to do what? You need to keep record of what you're doing. You write it down. What you have not done, you don't write it down. Once you start a task and you complete it, before you start another task, you want to write that down. Okay? Once you write that down, then you can start the next task. Now, let's assume in the event of writing the first task down, you make a mistake. When you make a mistake in such a scenario, you don't cancel it. You don't cancel it. As if a primary school pupil is trying to play with a pencil. You cancel with just one line, one straight line. Okay? You cancel with one straight line, and then you sign against it. You put a sign, you put your signature, and you put a date. Before you write, then you write the correct thing there. This is very, very important in record keeping. People say shit. So don't use it don't behave like a primary school pupil that will use a pencil to create a shade, on whatever he or she might have written on the paper. No, you just use one straight line to cancel whatever you might have written because you have made a mistake. And then put your signature and date, then you write the correct thing. Then you are free to move to the next task. Okay? Then rule number 6 is staff training. Staff training. Now, talking about staff training in this case is like talking about security of a country or talking about security of a state. If you have well-trained staff, believe me, you're going to get the profit because they are not going to be wasting your materials. They know the kind of materials to use, the quantity of materials to use, when to use it, and how to use it because they are well-trained. So what I will say in the essence, no amount of money spent on training is too much. Because you're going to get the result eventually. What is the result? You're going to have a product that is free from defect. You're going to have a defect-free product when you have what? Well-trained staff. Some people say train and retrain. Well, I would say continuous training. When you train your staff today on an issue, after a while, train them again. They're human beings and they have their own life too. Don't say, oh, they should know that by now. No. Even though they've undergone training on a certain thing, after I will train them again. Okay, and whatever, and like we said, no amount of money you spend on training can be too much, because you're going to get the result eventually. Because once you get a defect-free product, that is your result. Okay, then so training is something you cannot stop, and that cut across all levels of management. All levels of management. Nobody's too small, to be trained in a manufacturing company, and nobody's too big to be trained. Everybody needs to undergo training. Needs to undergo training all the time. Okay. Now, rule number 7 in good manufacturing practice. Sorry, in the rules of good manufacturing practice. Rule number 7 is practice of good hygiene. Practice good hygiene. Now, take for instance, when I was talking about somebody working on one side of the plant, and you have touched a product there. Before you touch another product on the other side of the plant, what do? You need to go wash your hands. Regular wash of hands is important in a typical manufacturing setup. That way, you're not going to be contaminated. You're not going to be contaminating products all over the place. So good hygiene is important to every staff. Then when you use the bathroom, believe me, it's important. Anytime you use the bathroom, either you do number 1, you do number 2, make sure you wash your hands before you leave the bathroom. Otherwise, you're going to contaminate the products. And you can even spread germs too. When you walk around in the premises without washing your hands, and you keep shaking hands with people, what are you doing? You're probably spreading germs. So we need to practice good hygiene in a typical manufacturing setup. Now, rule number 8, maintain facilities and equipment. Maintain facilities and equipment. What are we saying here? Now, when you have a facility, you don't just allow all those machines to continue to run day in, day out. No, you need to have what we call maintenance schedule. Okay, if what you do is, let's say for instance, you need to open up a machine, change the oil, tighten up some bolts and nuts, maybe once in 2 weeks, you need to do just that. Okay, it's maintenance, part of maintenance. Now, if you do that, it's going to save a lot of headache. You know why? If you don't do regular maintenance on your equipment, what you're going to have is total breakdown. When your equipment breaks down, then you're going to spend more money to fix the equipment. So that's why regular maintenance of facilities and equipment is very, very important if you want to have good manufacturing practice. Okay, you don't wait until the machine breaks down before you do the maintenance. What again? Another rule is maintain quality. What are we saying here? You want to make sure every step of a production, you put in what we call quality. You want to do your best, your very best at every stage. You don't want to wait until you get the final product and there's a defect on it before you start running around. No. From the scratch, you want to put quality in everything you do. Every step, make sure you do it right. If step A is not right, don't move to B. Because if A is not right and you move to B, then from B to C, when you get to C, you're going to have a combination of bad A and good B to get whatever you get in C. Eventually, the last thing, your final product, is going to be a screwed up product, a defect product, and you don't need that. Okay, so now for you to have a good quality, a quality product, you want to maintain quality in every steps of what you do in a typical manufacturing setup. Then the last but not the least of the rules that I have identified for the purpose of good manufacturing practice is what I call perform regular audits. Perform regular audits. What are we saying here? You have procedures laid down from A to Z, in order to get a good product, a quality product. You want to make sure at intervals you go back to check. You want to see whether what the staff are supposed to be doing, they are doing it. The way they're supposed to use an equipment, that's the same way they're using it. We want to make sure that what everybody is doing in your plant, they conform with what the setup standard. That is the goal. So without you, before the external body, that is the government agency, before they will come to audit your firm, okay, you need to do what we call internal audit on your own. You want to go back even behind the staff when they're not there. Check the machine. If it's dirty, then something is not right. Whoever is using that machine needs to be told that, look, you are the one working with this machine. It has not been cleaned in a while. What's going on? Look at your procedure. You need to be clean it. If it is once in 2 weeks, you need to adhere still to that. So you want to check every activity at intervals. It's called internal audit. So these are some of the rules I've identified in good manufacturing practice. Okay. Okay. I guess our time is up, and I think we're going to continue from here next week. Okay. I gave an assignment the last time we met. I told you to read product selection, suppliers, and manufacturers. I guess you did. So we're going to continue from here next week. You have a good weekend. Bye-bye.